Okay, very well. So, welcome everyone. Okay, bit more people joining. Awesome. So we can slowly get started. So, thanks again for being here. This is our third and the last opportunity to present your project in front of fellows, mentors, public. We'll have recording of this, of course, going public. So, I hope you prepared some presentations. We got five people signed up, but I got a message from Vukasin that he's sadly still in hospital and he won't be able to make it today. But coming from the previous call, we got Ovanikin first in the list. So if you are ready, if you're here, yeah, Ovanikin, feel free to kick it off with your presentation.
Yes, sir.
Awesome.
Let me just quickly share my screen.
Yeah, go for it.
Can you see my screen? Okay, great. Uh, Hi, everyone. I'm fellow Devin Day, Wanike on Discord, and I've been working on a project as part of my work for EPF Code 6, adding Postgres DB support as a backend for the Lighthouse Beacon node. So essentially, this work builds directly on the idea proposed by the Lighthouse team, and it addresses a real issue in production deployments. Um, so I'll be walking you through the motivation, design, current progress, and the roadmap for the project. So let's start with why this project matters. Uh, Currently, Lighthouse supports two database backends. There's the LevelDB and VetDB. So while LevelDB is fast, it is not designed for use over network file system, and that can lead to corruption in real-world setup. VetDB as well has similar limitations around concurrency and shared environments. Although this hasn't been like tested extensively, but it is implied by the team. And here's where Postgres comes in. It is reliable, production tested, and designed for concurrent access. It also works well over NFS, which makes it kind of suitable for the kind of solution that we want for this issue. The core idea of the project itself is to integrate PostgreSDB as an optional backend that conforms to a Lighthouse core trait abstraction, the key value store abstraction. So this implementation is will be fully async. To use SQLX for database access, and is gated behind a cargo feature flag. So ultimately, what this will do is like give users the ability to run Lighthouse on Postgres like they would do with LevelDB or RedDB. This helps in gaining reliability and flexibility without changing the core behavior of Lighthouse itself. So let me go to what's been done in the first month, which we just passed. So far, I've been able to design the database schema. I've also implemented get bytes, put bytes. I've also been able to wire Postgres backend into the code base using feature flags. So you can select Postgres currently like you would with VDB or LevelDB. And I've also been able to set up testing using Postgres instance via Docker. And also you can now test also. I was able to also test with the common test suite that is used for LevelDB and VetDB, and Postgres didn't give any issue. So over the coming months, I'll be expanding implementation, complete atomic batch writes, iterator functionality. I also focus on benchmarking, configuration integration in docs, prepare a proper and submit like a proper pull request to Lighthouse repo. I've submitted a PR already through which I've been able to get feedback from the reviewer and from my mentor. So by the fifth month, I intend to have uh, fully finalized the merge, be able to publish docs and potentially explore optional improvements like performance tuning or observability or whatever the team thinks is best for me to focus on. So what like challenges have I faced? So first is working with async traits and SQLX. This sort of has like a sort of complex, or should I say strict executor requirements. Then there's also translating Lighthouse batch operations into SQL transactions. The way Lighthouse already does it with the other databases, being able to transfer that into Postgres like SQL. I also need to like be able to make sure that Postgres matches or exceed uh, level DB and RedDB in terms of like performance. At least be able to meet that before we can do any tuning. And finally, making sure that you know CI setup works smoothly with Postgres. Yeah, how I'll define success for this project. Uh, that would be like that Postgres backend is fully integrated, is functional, and passes all existing tests like it's currently doing without much hassle. That it can be selected via config and feature flag and runs reliably even in environments where level DB and red DB fail. Also, is that like I think one would also be that the opportunity that it opens up for like future use cases like metric dashboards or SQL based SQL based querying or like enterprise deployment patterns. Yeah. So yeah, that's it for me. Thanks so much for listening. I love any feedback, suggestions, or ideas that can help improve the project. Yeah, happy to take questions. Thank you. Thank you, Mario.
I don't have any questions coming from me, but yeah, thank you so much, Mannequin. Hey,
Thank you, Mario. Thank you, everyone.
yeah, yeah, awesome. Yeah, thanks for making the presentation for us. And so next would be Lucasen, who couldn't make it. So we need to skip him. And there is Rahul, Guha Rahul, is next.
Hi, am I audible?
Hey,
Okay, let me share my screen. I think it's visible, right? Okay, so let's get started. So basically, what will be working on is implementing Era file support in Lodestar, mainly Era 1. So let's see what it's all about. So like a little background check on why we actually need it and what's the fuss all about. So for us for a client to basically sync from Genesis, it has to get the data from somewhere, and the and and CL clients basically serve that beacon chain history via P2P now, so that people who want to sync from Genesis can do so. But if you don't want to do so, then we have this alternative method called checkpoint sync, which is based on weak subjectivity. We can use that to sync faster. But nevertheless, the problem still is that post merge, the block size and history like expanded very much. And recently, there has been this EIP called EIP uh, 44s, where where clients don't need to serve pre-merge history block via the P2P layer. So that's a relief. So, like, what's the problem? So the problem is that we can't share this data in a standardized way, and syncing from Genesis requires massive bandwidth and storage. And also, if the client, if there is some problems with the client P2P spec or something related to the uh, data loss, it cannot be recovered. We have to resync from Genesis, and also with 4 force execution, clients need to stop serving block bodies after that are older than 1 year, but still the data is a few hundred GBs. So one of the solutions that was presented is era files. There was also two other solutions. One was Portal Network, which was kind of disbanded by EF, and there is also another EIP. But this is the main solution that is being implemented. So what is era files? Era files is a flat type length value file format for finalized block and consensus state data. We have also era files for different types of data, such as blobs or execution data. But era one, which I will be working on, is basically implementing the beacon chain data. So it basically covers 8,192 slots, which is about 27 hours, and it is also verifiable. The files can be served via simple HTTP or torrents, and it reduces the need for all the nodes to store all the historical data. We can just get the files directly from a client and use that. So let's see what the existing implementations there are in the market. So uh, currently, only Nimbus has support for, and Nimbus and Besu has support from support for Era 1 files. And there is also some reference implementations of Python and Nim. The Era files are hosted in this URL, which can be served via any HTTP service. And also there is this script from a core dev where we can use a bash shell to basically download all the data itself. So that's very easy to do. And also my deliverables over the few months would be implementing the reading and production of era files. Probably a CLI tool would be great. And also we are gonna use the era files to serve beacon block by range, and maybe I will be also be working on the era file for blobs, but it's still in a draft PR by Nimbus. uh, yeah, I mean, that's all. It's not a major feature, but yeah, I think it's what we're working on. Thank you. Any questions from any?
Thank you, Rahul. Yeah, I would just add, because you mentioned that there are the HTTP endpoints for downloading the error files, but that cannot really be like a reliable source of the history. And the question is whether you are seeding the error files. Like there is the torrent file. I have my it's like 400 gigs, and I'm seeding it on my server. So um, another addition is that you can just seed the files as a on torrent.
Sure, sure, sure.
It's a good
Uh,
plausible deniability, if you use torrent and your ISP complains about too many peer-to-peer connections. Oh, it's not movies, it's the error files.
yeah.
Um, yeah, so we just wanted to add that, and yeah, it looks good. Thank you so much.
Mm.
Any more questions, comments, anyone? Maybe a question is like whether you looked into the Zig as part of their code base, that maybe it could improve performance. Whether you're going to do it all in TypeScript, or you looked into the possibilities of doing something in Zig as well.
Yeah, so the current situation with the Zig thing with Lodestar is that they are still deciding on which FFI to use. Like, there is a discussion between whether we will use Nappy or whether there is this other system that they might use. So the mainly Cayman and all the chats are working on that, and like I'm working on the library side, but I think that comes a bit later because they are still finalizing on the main FFI layer that they are gonna use. So yeah, I mean, if we have something like that, then there is obviously a chance for performance enhancement.
Okay, cool. Yeah, thanks for that. Okay, thanks for Rahul. If there are no more questions, I think we can move on then. Thank you.
Yeah, thank you for your time.
Yeah. Next up, we have Jimmy and the team. Jimmy and Aman and Ritesh. Aman already presented, so if you guys have, yeah.
Yeah, I will just add a few words in addition to amount presentations. Uh, so I previously I'm interested in the Redine CKVM benchmarking issue, and I submitted a PR proposal, but then realized that the Aman and also Ritish is also working on it. So we are going to join force together, and each of us will pick a different CKVM to work on. And uh, we actually Greta has already done quite some work on the benchmarking on RISC 0 and SP1. And so we need to work on other CKV VM only, but uh, like we are still looking into the source codes and trying to see how they actually put the state transition functions into the gas in the ZKVM. Uh, Initially, we were trying to work on OpenVM, seeing that there's the most documented, well documented CKVM. But then we realized that the core team of OpenVM is going to work on it, so we can pick other CKVM, and I myself is going to pick previous Pickle, and then Aman and Ritish will make the decisions later. Yeah, that's the updates on my side. And oh, by the way, and I have to thanks a lot on another fellow Jun Song and also Yuan. I'm not sure how to pronounce his name on their works on doing the CKVM benchmarking on RIM. I also study about the source codes and learned a lot from there. Is Retish here? I wonder. Do you want to add a few words if you are here? Okay. Yeah, that's my my update. Okay, thank you.
Yeah, I have a question. Can you hear me?
Yes, yes, yes.
Yeah. So, since the repository is not public yet, I mean, what is the progress that you made on the Grantine code base? I mean, I would be interested to know or like learn from your ideas or understand something more than. So I'm working on the RIM side, but I was
Right.
curious, and also when is it going to be public so that I can also read your progress?
Okay. I haven't done much progress on it yet, to be frank, but I don't know like when they are going to make, because that's not up to my decision. So when it's going to make it public, I can check for you like when they're going to make public. Yeah, I'm not sure like what is their consideration. Well, so, yeah,
Thanks. So,
but I can check for you and let you know in later in this.
oh, no problem, no problem. I'm also in your group chat. And so, is it true that the main problem that you face, so the problem that is posed by Saulius, is just running the zkVM with a very large number of validators? What is the progress on that?
Uh, the thing is, they they have a script to being able to like generate the large to generate the large amount of validators, but I haven't able to successfully execute that script yet. So I need to get back to you on this.
Yeah, thanks. Thanks a lot.
Um, Hi, hi everyone. Hi. Um, I'm Ellie, and today I want to talk about the ephemeral implementation and base 2. It's a um, it's a Java-based execution client. And okay, about the presentation, I tried to I don't know. I tried to make it simple to understand, and maybe a little bit of visualization on it. And so I thought maybe if at the end of the day people can describe this ephemeral testnet with a few sentences, then maybe I would be happy. So I turn off my camera and want to share the my slides. Okay, how to share my slides? I see lots here, but wait, yeah, I guess this is the maybe right one. So okay, and do you see?
Yep, we can see it.
Thank you, thank you, thank you. So let's go to the how I can. Okay. Yes. Oh no. Oh no. Okay, this is, as I said, this is the ephemeral implementation on Besu. And okay, ephemeral is a yeah, it's a short-lived testnet, public testnet, and actually it made me think of a butterfly. It has a short lifespan, right? So what is ephemeral? why, how, where. We are going to talk about it a little bit. It's EIP 6916. As I said, it's a short-lived public testnet, and after a while, it will automatically reset on a cycle. Now the cycle is 28 days. And then it's like other testnet, like other network. It starts from a Genesis file, and there is a little bit difference here, which I will talk about it later. So why FMRE? How it benefits us? It solves some problems with the like other kind of testnets, long running testnets. One problem with those testnets is this state plot, right? And other one is the lack of testnet funds, which maybe most of us have run into that issue in the past. So also the consensus issue, which is also important and has happened on other testnets recently, like inactive validators and other problems that comes with this consensus. So, and some use case of it, it can be many, but for now we can use it as if someone is running a staking node. Maybe they want to test it before a real mainnet run, so they can try it on ephemery. Would be very good option. And also it's for contracts that are applications that are going to be, that's not important to be on the testnet for a very long time. I can say for most cases it works, because maybe it's very critical for protocols that want to their contracts be, I don't know, for a long time on a testnet. But for other applications, it's really not a big deal. So you test it. Maybe you just want your coworker from other side of the world just see the parameters of the contract, that it is working, see the application, test it. It's not a big deal being a short time testnet here. I think it's very helpful actually. Also, and also you are not going to have this testnet fines like with testing contracts. And also, breaking changes in client implementation. As we know, client implementation, we test what we are going to implement on clients. So it's very good to run it on a testnet, test the client, and with a very low cost, because this testnet is not going to use your resource and your computer. The state blast is not going to happen. I mean, isn't it cool? Yeah, it's cool. And also it's public. I mean, maybe you can for implementation you can run a private network, and maybe on some, maybe all client doesn't provide a private network. But the private network is isolated. But this is maybe this can be a better option. And yeah, how ephemeral testnet, how it's working. A little bit more detail into it. Yeah, it starts with a Genesis file. It has a Genesis 0 file, which is hard coded in the client. The client who are going to support it have to has it on the client implementation, and it is called Genesis 0. So here is the difference. The other network, you start from a Genesis and you go on. There is no other Genesis. I mean, here the Genesis meaning is more flow, is a little bit fluid. Every at the start of every period, you start with a brand new Genesis, which is not very different from the Genesis 0 actually. Only a few parameters are going to be changed, right? And these few parameters you derive it from the Genesis, and you derive from Genesis 0, and it's important to know that the all Genesis between are not going to be initialized. These parameters are going to be calculated only by, I don't know, a sum, a multiplier, divided by a number, easily. Because, for example, here we want to know what's Genesis 1, right? So it's chain ID is going to be chain ID plus 1, right? Chain ID from Genesis 0, which we have it in the client, is hard-coded. So Genesis ID for this, the next Genesis is going to be Genesis ID from Genesis 0 plus 1, right? Same with the timestamp. Timestamp is going to be timestamp from the previous Genesis, which here in this case is Genesis 0 plus 28 days, right? And so this is an example for Genesis 1. And what if it's not Genesis 1 and we are at some point in the time and we want to calculate Genesis n? We know when now is we have a timestamp now, right? So we can calculate the number n. The number n is calculated, then you can calculate the chain ID. Chain ID is what is this? The chain ID from Genesis 0 plus n. You already found n, right? So this is how we find this parameters. So there's no there is no heavy calculations, right, from Genesis 0 to Genesis n. No, it's just as this simple that I'm describing it. So timestamp is going to be timestamp from Genesis 0 plus 28, which is the period, multiplied by n. And it's here I wrote it in days. And it's in seconds actually. So it is. So this Genesis n is derived from Genesis 0, and all the Genesis files between are not going to be initialized. We just find the parameters of Genesis n. So now imagine that we are on day 3, okay, of this period, this 28 days period, and we want to like add a black on top of it. We want to build a black. So we know where when is now, like the current start timestamp is now, okay, as we are on day 3 of Genesis, of some Genesis, we don't know. because we are going to find it. Maybe we need to find it, right? So here we ask like if the current genesis exists. Then if no, then we derive it from the genesis 0. So how I described it in the last slide, right? If no, if yes, okay, we have a genesis. It exists. Okay. So is it, the question is it still valid? Like we are on day 3 or we are on day like 29, right? So if yes, if it's still valid, in this case we are on day 3, right? It's valid. So we build the block like other testnets. Uh, Okay, yeah, sure. It's not going to take too much time. If not, then it's going to. Yeah, this is actually, I want to get to the point that there are what I'm going to implement, right? Just so here, if it is no, then the network start to reset, and the reset we start to build this genesis, and yeah. How yeah, this reset functionality is the main part actually. It's, yeah, we derived the new genesis parameter with this reset. When the network is going to reset, this I mean that n, right? And this chain ID timestamp, which I described. So and also the we initiate this new genesis, and we discard the old data. The state word, everything is going to be refreshed, right? And it's going to be refreshed automatically. So there's no one going to I don't know, change something, do something manually. It has to be automatically. So this state word should be the old state word should be removed, and etc. Right? So what where ephemeri, I mean, is ready for now, or has been implemented. Yeah, and most testnets is available, whether it's manually or yeah, implemented almost completely. So I wrote the names of people from previous cohorts. So Lodestar Angus by Holly from cohort 4, Lighthouse and Res by Terry from cohort 4. So maybe you want to check out their work, and if you want to continue and the work that they've done. And also Besu and Teku by Glory, with cohort 5, which I'm going to continue on this one, like working on Besu and Teku. And yeah, which Besu and Teku are the pair client, Java-based pair client for yeah, Besu is execution, as I said. Teku is Teku is consensus client. I'm sorry for the mistake. And yeah, so what's my main task and this and this project is going to be this functionality of automatically reset, and the database, as I said, is going to be reset, and yeah, the state should be refreshed. My timeline is I'm not sure. I mean, I based on what I anticipated for now is like maybe I wish to finish this reset functionality and by I don't know by big 10 11 and then and that work work on the Teku side, right? So for now I'm starting on Besu, implementing it on Besu, and then I want to deep dive into Teku as well. So yeah, this is the timeline. I'm not still sure about it. I don't know. I'm very at very beginning of it. Okay, and also the I don't know. Maybe it needs to be developed parallel. I mean, maybe I'm just thinking that like within week 10 it's going to be finished. Maybe it's not going to be finished. Maybe I should work on Teku a little bit, do some change on it, and then come back on Besu. So that's why I'm not very sure about the timeline. So the next step, I'm going to I'm going to see what's available for now. I mean, in detail, right? I should run it on. I should run this testnet on this to clients and see what's really available. And yeah, I've checked the code base of Besu, but no, not much on Teku. So yeah, I should. I should work on it. I mean, to see how the path is going to be, right? And yeah, thanks for listening. And if you have any question, you can ask. And also, thank you, Mario, for your comments on my proposal. I will get back to it. Yeah, thank you so much. Yeah, any questions, please?
Thank you, Ali. Yeah, any
Yeah.
comments, questions? I would just point out in the last slide you had Teku as execution client. There it's a consensus client. Just a
Yeah, sorry.
just a typo you had in the thing. Yeah. Yeah. Any thoughts? Any comments? Um, yeah, I already commented on your proposal, so I don't have anything to add now. But if there are any more thoughts, feel free to speak up. And also because it's our last presentation of today, we have a couple of minutes left. If there are anyone else who wants to give any update or share about their plans, somebody who haven't done so yet. Anyone? Okay. Well, if there are no more thoughts from anyone, no more comments, no more questions, we can wrap it up. Just wanted to mention again, this was the last office hours dedicated to the project presentations, and next week we will have AMA, or next week we'll start office hours with AMA sessions. We're going to have Barnabas from PandaOps for the next session. Going to open the issue so you can learn some details, post questions if you cannot make it there next week. It will be more focused on like local prototyping. You can get some tips about how to test your run your stuff when you are actually developing with the clients, to get some thoughts on some advice on the development process. So yeah, we'll see you next week, Monday on the stand up and Wednesday on the next office hours. So that's it. Yeah, got some minutes left. Cool. Any questions, comments? Anyone? Was it everything? Otherwise, yeah. Thank you so much, everybody. Thank you for the lovely presentations. Awesome.
Thank you.